Okay, this is the answer for Thursday night's homework. So this is the question for the amusement park ride. So you might find this interesting because, when you go on the rides, they have those signs up that say, oh, 40 minutes, wait until you get on, a 40-minute wait for the ride. Well, this is how they figure all this stuff out. So hopefully you find this a little interesting. Okay, so for part A, all right, so let's talk about what's happening. So before the park even opens, there are 700 people waiting to get into the park. So 700 on waiting. Okay, so they're not even in the park yet. Okay, once the park opens, they will take passengers for until 8 p.m., 8 hours. I guess we're assuming they open at noon. It doesn't really matter. Okay. Well, there is a line. People go onto the ride at a rate of 800 people per hour. So on the ride is 800 per hour. And then they're going to give you a graph, and this is the graph that's here, and this is showing you the rate at which people are arriving at the ride. Okay, so obviously, if people are arriving at a rate higher than 800 per hour, you're going to have a line, right? Because 800 people can go on the ride per hour. Okay, so part A is asking, how many people are arriving between 0 and 3? So here's 0 to 3. Okay, so from 0 to 3, now remember we don't have a function, but look at, we have a beautiful trapezoid right here, and then we have a beautiful trapezoid right here. And since they're exact trapezoids, we can just find the areas of those, and that will tell us how many people arrive, because this is the graph of people arriving, okay? So we'll do the first, so we're going to have two trapezoids. Let's get it set up. Okay, the first trapezoid has a height right here from 0 to 2, and the second one has a height of 1. Okay, so looking at the first one, this will be our base 1, and that's 1,000. And this is our base 2, and that's 1,200. And then let's look at the other trapezoid. So here's base 1, which is 1,200. And this is base 2, which is 800. Okay, now we just have to do this math. So the 1/2 and the 2 cancel out, and you're going to get 2,200 here. And then you're going to get 1/2 of 2,000, which gives you 1,000. Add them together, and you get 3,200. So there were 3,200 people. So what are your point values? They are... this whole setup thing is 1 point, and then finding your answer is 1 point. They also accepted if you wrote how many people are there from 0 to 3 of R of t dt, they would have accepted that as well. I don't think you would have done that because you would be doing this. Okay, so that is part A. Okay, part B. You have to look at the number of people that are waiting in line between 2 and 3. So here's between 2 and 3 right here. And decide if it's increasing or not. Increasing or decreasing. The number of people that are waiting online. So at the very beginning I had said that they can put 800 people on the ride per hour. So we have to see what's happening just between 2 and 3. So here's 2 and 3 right here. Okay, so let's figure out if we use the trapezoid formula. I think we need more room than that. Length was 1. Okay, so base 1 was 1,200. The other base was 800. So we have 1/2 of 2,000, which gives us 1,000. Okay, so 800 people can get on the ride, but 1,000 people are arriving. So therefore, the number of people waiting in line is increasing. So if you had gotten an answer less than 800, then the people on the line would be decreasing because they're getting on the line faster than they're coming. Okay, so that's B. Okay, so part C is asking, when is the line for the ride the longest? So remember, again, we were talking about that 800 number. So the 800 number is right here. So if it's anything over here, right, because these numbers are all going to be less than 800, that's going to be when the lines are the smallest, because the people coming in is smaller than the amount that they can get on it for each time. So either it's going to be the longest at 0, or at 1, or at 2, but not at 3, because at 3 it's already going to be down to 800. Okay, so that's what we're dealing with. I'm just going to erase this part over here. Okay, so what was the rate that people are coming in at time equals 0? It would be right there, and that would be 1,000. Okay, what's happening at 1? Looks like 1,100. What's happening at 2? It's 1,200. Well, let's just go one more just in case. And at 3, it was 800. So this is the people that were coming in. And so they're coming in, and there's all these people, everything. Let me get another color. So all these people, until it got to time t equals 3, it was increasing. And then once it got to 3 over here, then it started to decrease. So let's go back to the question. At what time is the line for the ride the longest? It's going to be, sorry about that. I'm just very popular and people are constantly calling me. Okay, so anyhow, I don't really remember what I was up to, but once it gets to t equals 3, that's when it starts decreasing. So therefore, the longest wait would be at 3 over here, right? Because all these people over here, there was building up and building up before finally it started leveling off. So I'm sure you've been to an amusement park where, like, later on in the day, you don't have to wait online because it gets less and less crowded. So the question is, at what time t is the line for the ride the longest? So you're going to say at t equals 3, the line was the longest. And then there's a second part to this. Well, how many people are online at that time? Okay, so this is what you have to figure out now. Okay, first of all, there were 700 people waiting at the gate when you first walked in. So there's 700 people. Okay, then how many people were there at t equals 3? So that would be this entire area here, but we already did that on part A, so we know that 3,200 people came. But so this together will give you 3,900. But remember, 800 people every hour are getting on the ride, and so this would be times 3 hours. So that means 2,400 people went on the ride. So if you do 3,900 minus 2,400, that means that there are 1,500 people that, they're still waiting. So you're going to say at t equals 3, the line was the longest when there are 1,500 people online. And that's why you end up waiting 2 hours to go on a ride. All right, so this is the point values. Let's see. So if you identify t equals 3 as the winner, that's 1 point. If you get the number of people that are online, 1,500, that's 1 point. And your justification, which would be all the work that you've shown, that was also worth 1 point. Okay, and now for part D, and I think this is a little tricky. It is worth 3 points, so I'm going to go over it. So the question is to write an equation, you don't have to solve it, that would just be a general equation. It says of an integral expression of r, meaning like you don't have an exact number, okay? Of when the earliest time there would be no longer a line for the ride. Okay, so you have to think of all the people that are coming in. So 700 people are waiting to come in, plus all the people that are going to come on to the ride, and they're saying to call it R. So you could say R of T, R of whatever you want. In their answer key they do R of S, but it really wouldn't matter. Okay, so what is the time? Well, we don't know. That's what they're saying. They want it to be like unknown. So it's the time going from 0 to some time t. Okay, but remember, after all that, you have to subtract 800 people for every hour when they you know, going onto the ride. Okay, so the point values for this were, if you just considered 800t, that was worth 1 point. If you have the integral, that's worth 1 point. And putting this whole thing together, oh, we have to write an equation, sorry. Okay, so if there's no longer a line for the ride, that means that it would be a minimum, right? So what do? You have to set that equal to 0. So if you set it if you did this whole thing, that was 1 more point. But if anywhere you just wrote like 800t, you would get 1 point for that. So that's why you should always write anything and everything, because you just never know where the points will come from. Okay, so that completes the amusement park ride.